all the containers that pack food, beverage, cosmetic, medicines, and daily necessity, all of them produced by bromodine. Bromodine is a manufacturing process for forming hollow plastic parts. It is also used for forming glass bottles or other hollow shapes. In general, there are three main types of bromodine: extrusion bromodine, injection bromodine, and injection starch bromodine. The bromodine process begins with softening plastic by heating a preform or parison. The parison is a tube-like piece of plastic with a hole in one end through which compressed air can enter. The plastic workpiece is then clamped into a mold and air is blown into it. The air pressure inflates the plastic, which conforms to the mold. Once the plastic has cooled and hardened, the mold opens and the part is injected. Water channels within the mold assist cooling. The process principle comes from the idea of glass blowing. Inoco Fagreen and William Copcake produced a bromodine machine and sold it to Hartford Empire Company in 1938. This was the beginning of the commercial bromodine process. During the 1940s, the variety and the number of products were still very limited, and therefore bromodine didn't take off until later. Once the variety and the production rates went up, the number of products created soon followed. The technical mechanism needed to produce robotic workpieces using the blow technique were established very early on. Because glass is very breakable, after the introduction of plastic was used to replace glass in some cases. The first mass production of plastic bottles was done in America in 1939. Germany started using this technology a little bit later, but is currently one of the leading manufacturers of bromodine machines. In the United States of soft drink industry, the number of plastic containers went from zero in 1977 to billion pieces in 1999. Today, an even greater number of products are brought, and it is expected to keep increasing. For amorphous metals, also known as bulk metallic glasses, bromodine has been recently demonstrated under pressure and temperatures comparable to plastic bromodine. In extrusion, bromodine plastic is melted and extruded into a hollow tube, forming a tube-like piece of plastic with a hollow in one end for compressive gas known as a parison. The parison is captured by closing it into a cold metal mold. Air is blown into the parison, inflating it into the shape of hollow bottle, container, or pot. After the plastic has cooled, the mold is opened and the pot is injected. Straight extrusion molding is a way of propelling material forward similar to injection molding, whereby an ultramid screw turns feeding plastic material down a heated tube. Once the plastic is melted, the screw stops rotating and linearly moves to push the melt out. With the accumulator mass, accumulator gathers melted plastic, and after the previous mold has cooled and enough plastic has accumulated, a load pushes the melted plastic and forms the parison. In this case, the screw may turn continuously or intermittently. With continuously extrusion, the weight of the parison drags the parison and makes calibrating the wall thickness difficult. The accumulator heat or reciprocating screw must use hydraulic system to push the parison out quickly, reducing the effect of the weight on the allowing pressure control over the wall thickness by adjusting the die gap with a parison programming device. Continuous extrusion equipment includes rotary wells, molding systems, and shuttle machinery, while intermittent extrusion machinery includes reciprocating screw machinery and accumulator heat machinery. Containers such as jars often have an excess of material due to the molding process. This is trimmed off by spying a cutting blade around the container, which separates the material. The excess plastic is then recycled to create new molding. Spin trimmers are used on a number of materials such as PVC, HDPE, and PE, P and LDPE. Different types of the materials have their own physical characteristics affecting trimming. For example, moldings produced from amorphous materials are much more difficult to trim than crystalline materials. Titanium nitride coated blends are often used rather than stainless steel to increase life by a factor of 13 times. Injection molding. This process is used for the production of hollow glass and plastic objects in large quantities. In the IBM process, the polymer is injection molded onto a carpin. Then the carpin is rotated to a molding station to be inflated and cooled. This is the least used of the cerebral molding process and is typically used to make small medical and single-serve bottles. The process is divided into three steps: injection, blowing, and ejection. The injection molding machine is based on an extruder barrel and screw assembly which melts the polymer. The molten polymer is fed into a hot runner manifold where it is injected through nozzles into a heated cavity and cupping. The cavity mold forms the external shape and is clamped around a core rod which forms the internal shape of the preform. The preform consists of a fully formed bottle jar neck with a thick tube of polymer attached, which will form the body, similar in appearance to a test tube with a threaded neck. The preform mold opens and the core rod is rotated and clamped into the hollow child blow mold. The end of the core rod opens and allows compressed air into the preform, which inflates it into the finished article shape. After a cooling period, the blow mold opens and the core rod is rotated to the injection position. The finished article is stripped of the core and core rod, and as an option can be tested prior to packing. The preform and blow mold can have many cavities, typically 3 to 16, depending on the article size and the required output. There are 3 sets of core loads, which allow concurrent preform injection, blow molding, and injection. Injection stretch blow molding has two main different methods, namely single stage and double stage process. The single stage process is then again broken down into 3 station and 4 station machines. Single stage. In the single-stage process, both preform manufacture and bottle blowing is performed in the same machine. The order for station method of injection, reheat, stretch, blow, and injection is more costly than the 3-station machine, which eliminates the reheat stage and uses latent heat in the preform, thus saving cost of energy to reheat and 25% reduction in touring. The process explained imagery. The molecules are small rod balls. When together, they have large air gaps and small surface contact. By first stretch the molecules vertically, then blowing to stretch horizontally. The biaxial stretch makes the molecules a cross shape. These crosses fit together, leaving little space as more surface area is contacted, thus making the material less porous and increasing barrier stretch against permeation. This process also increases the said to be ideal for filling with carbonated drinks. In the two-stage injection stretch bro molding process, the plastic is first molded into a preform using the injection molding process. These preforms are produced with the necks of the bottles, including threads. The finish on one end. These preforms are packaged and fed later after cooling into a reheated stretch bro molding machine. In the ISBM process, the preforms are heated, typically using infrared heaters above their glass transition temperature, then blow using high pressure air into bottles using metal blow molds. The preform is always stretched with a coral as part of the process. The principles and the classification of the process have been finished. Next, I will tell the difference between blow molding and injection molding. For the injection molding, is a manufacturing process for producing parts by injection material into a mold or mold. Injection molding can be performed with a host of materials, many including metals, for which the process is called die casting, glasses, elastomer, confections, and most commonly thermoplastic and thermosetting polymers. Material for the part is fed into a heated barrel, mixed using a helical screw, and injected into a mold cavity where it cools and hardens to the configuration of the cavity. After a product is designed, usually by an industrial designer or an engineer, molds are made by a mold maker or tool maker from metal, usually either steel or aluminum, and the pressure machine to form the features the design part. Injection molding is widely used for manufacturing a variety of parts, from the smallest components to entire body panels of cars. Advanced in 3D printing technology using photopolymers that don't melt during the injection molding of some lower temperatures. There can be used for some simple injection molds. Injection molds uses a special purpose machine that has three parts: the injection unit, the mold, and the clamp. Parts to be injection molded must be very carefully designed to facilitate the molding process. The material used for the part, the design shape and the features of the part, the material of the mold, and the property of the molding machine must all be taken into account. The versatility of injection molding is facilitated by this breadth of design considerations and possibilities. Applications. Injection molding is used to create many things such as wire spoons, packing bottle caps, automotive parts and components, toys, pocket comps, some musical instruments and parts of them, one-piece chairs and small table storage containers, methanol parts, including jars and most other plastic products available today. Injection molding is the most common modern method of manufacturing plastic parts. It is ideal for producing high value of the same object. What's the difference? What's the difference between blow molding and injection molding, and what they have in common? Injection molding and blow molding are both high production volume manufacturing technologies that forms plastic into many different shapes and sizes. Injection molding and blow molding are both high production volume manufacturing technologies that form plastic into many different shapes and sizes. Injection molding is used for complex solid components, whereas blow molding is used for thin-walled hollow parts. Injection molding forces plastic into a mold under high pressure. Blow molding, on the other hand, expands a hollow tube of plastic into a mold using compressed air. Blow molding is generally cheaper than injection molding. This because blow molded products are less complex and therefore the required tooling is cheaper. In addition, injection molding requires heavy-duty hydraulic rings to inject the plastic raw material and to keep the mold from leaking plastic during the injection molding phases. Blow molding can produce single components, hollow containers, which would be impossible to make with injection molding. And blow molding is less expensive than injection molding. Blow molding is performed at lower pressure than injection molding, allowing the use of less expensive tooling and equipment. 3. Blow molding is only applicable to thin-walled hollow parts. That being the case, it is limited to such application. It can't be used for thin-walled products. Three, blow molding is cheaper. is cheaper than injection molding. Molding 3. Molding is only applicable to thin-walled hollow parts. That being the case, it is limited to such applications. It can be used for thick-walled products. The parts need to be trimmed off at the top and the bottom of the part after molding. Injection molding typically requires no surface finish. In summary, molding is more cheaper, but if you need paint or good surface finish, it will be cost a lot because the surface is low, but the surface of injection molding is very smooth. We can do finish it directly. Today, I introduced the molding and injection molding. Added a point. Molding have three typologies: extrusion molding, and spin trimming, and injection molding. Injection molding is very similar to the injection molding. Injection stretch molding actually have two stage. Single stage in the two main different methods, namely single stage and the double stage process. The single stage process is then again broken down into 3-station and 4-station machines. In the single station process, both perform manufacture and bottle blowing is performed in the same machine. The older 4-station method of injection, reheat, stretch blow, and injection is more costly than the 3-station machine, which eliminates the reheat stage and use latent heat in the preform, thus saving cost of energy to reheat and 25% reduction in touring. 25% reduction in touring. The process explained. Image the molecules are small rolled balls. When together, they have large air gaps and small surface contact. By first strange the molecules vertically, then blowing to stretch horizontally. The biaxial stretch makes the molecules a close shape. These crosses fit together, leaving little space as more surface area is contacted, thus making the material less and increasing barrier stretch against permeation. This process also increases the stretch to be ideal for filling with carbonated drinks. In the 2-stage injection stretch molding process, the plastic is first molded into a preform using the injection molding process. These preforms are produced with the necks of the bottles, including threads on the end. These performers are packaged and fed later into a reheat stretchable molding machine. In the ISBM process, the performers are heated above their glass transition temperatures, then blow using high pressure air into bottles using metal blow molds. The perform is always stretched with a core rod as part of the process. Okay, next, my colleague Gloria will go on. Thanks for your time.
Hello everyone, I'm Gloria, and now let me share some information about rapid prototyping and low-value manufacturing. If you have any questions, feel free to ask in the comments. Of course, don't forget to follow me. So first one is, what is prototyping service? Rapid prototyping is the process of creating a physical sample of a new product design concept, and this is done at the preliminary stage before final production, and is particularly beneficial and when ensuring that the finished product like looks and feels and performance as anticipated. Rapid prototyping is used by new product developers for a variety of reasons. They are used for functional testing and approvals and design reversion and crowdfunding campaigns. Trade show models as a stepping stone to low-value manufacturing, prototypes frequently inspire redesigns and refinements, and other changes that would not have been visible from a computer graphic. Therefore, they are useful for optimizing a design before committing resource to greater volumes. Correcting design flaws earlier in the development process can more than offset the cost of the prototype, making them sensible investments. About the advantages of rapid prototyping, rapid prototyping assists you in making the most of the stage of the product development cycle. Working with professional engineers has various advantages, like reduced cost. Rapid prototyping allows you to swiftly and efficiently turn your concept into a test subject. Earlier in the development process, time-saving months get you one step closer to a finished product that pays for itself. Whether you are a well-known global brand or a tiny firm, any cost-cutting measure can boost your bottom line. Second is supporting functionality testing. Your product accuracy decides how your product looks and functions. Testing and retesting allows you to fine-tune your ideas and transform them into successful solutions that are more likely to succeed. That it provides a good user experience. That it provides a good user experience. Is it achieving your objectives? At this point, you can identify characteristics that require additional improvement and prospective area for expansion. About reduce risk, if you product designers identify significant concerns during the testing phase, those crucial design defects can be addressed before your product is released to the public. It's considerably easier to correct a prototype than it is to fix a product that has already been sent to customers. A thorough review of your design reduces the likelihood of failure in the long run. The next one is save time. Repeat prototyping is a valuable means for saving time during the development process by quickly creating and iterating prototypes of a product or solution. It allows you to validate ideas, collect feedback, and make necessary improvements before investing significant time and resource in final implementation. Yeah, implementation. So the about the repair prototyping factory, maybe you want to know what kind of services are included in repair prototypes. Various technologies are available for repair prototyping in manufacturing, including layered additive manufacturing, high-speed machining and casting, custom molding, and extruding. Additive manufacturing is the most popular process for repair prototyping. Traditional process including subtractive and additive manufacturing. Subtractive manufacturing covers a block of material to create the desired parts, while additive manufacturing applies solid or liquid material to the desired shape. You can select it from a variety of repair prototyping months for your production requirements. Depending on the repair prototyping firm you deal with, distinct processes have distinct benefits, giving your manufacturing company flexibility and variety. About the types of repair prototyping, it's including CNC prototyping and CNC. About the CNC prototyping is a good alternative since it can produce most quality of prototypes in the reasonable short time when compared to other technologies. CNC prototype machining makes it simple to create many types of prototypes. Appearance prototypes, for example, can offer visual information about how the final element will look or behave. However, functional prototypes require greater tolerance and a greater emphasis on product structure and stability. Advantage of CNC machining for prototypes like cost 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 effective. If you only require a few prototypes, CNC machining is most cost effective alternative. Unlike injection molding, which may take many months to prepare the model and tolerance, CNC prototype machining can begin immediately after the layout and tolerance are established. high tolerance. Another feature that contributes to the rapid development of repairs is their large tolerance range. Unlike 3D printing, your prototypes can be as increased as the end product. This is a significant benefit for those who intend to use the prototypes for structure and functional testing. Also have high restoration. CNC machined prototypes as opposed to 3D printer prototypes have normal similarly to the product because machining centers are complex capability of generate and use parts and prototypes. Prototypes that are near to the final product can be made. One of the reasons engineering materials are favorable for prototyping in their acceptation machinability. This means that engineers can utilize the same or similar materials or prototypes and final parts. Furthermore, unlike printed parts, machined products are generally stronger and do not have any weak points. Along special access. However, the machining process can also be used to uh, duplicate other operations, such as sheet metal shaping. And working casting is a manufacturing month for making accurate prototypes or low-value goods. Underworking and liquid materials are injected into a silicon model to ensure flawless replication of tensing features and equal material distribution. The advantages of vacuum casting have fine details and textures are prototypes computed by vacuum casting, and a vacuum casting is a cost-effective way for creating tiny quality. Prototypes and small bunch production have short lead time. Maybe you are very interested in this one. Design flexibility with sharp parts and complex geometries. Vacuum casting prototypes are useful for testing and validation before to production. Rapid injection molding injects thermoplastic regions into an aluminum model and produces strong, high-quality parts. It's the industry standard for plastic parts production and allows for material flexibility in prototyping. Advantages how molded parts are created using an array of high-quality materials. How an exceptional surface finish and so as an excellent indicator of manufacturing flexibility during the production process. The 3D printing service repeat prototyping comes in various forms depending on your requirements. Each bonded will improve your product with different features. Choosing the proper fast prototyping types for your production is crucial to achieving the greatest reason from your manufacturing procedure. Before deciding on the best solution for your manufacturing process, you should consult with the quickly prototyping firm with which you are working. How to choose a rapid prototyping service? It can be a challenge to select the best rapid prototyping service, particularly when time is a crucial factor. Having complex design doesn't always mean shorter lead time. The materials utilized are also significant in terms of scheduling and packaging, so it's important to have a clear understanding of all aspects before setting inspection. So here are a few things to consider. Firstly, there are several questions you need to consider. Is my design too complex for an instructor and functional model? And which is more important to me, the quality or speed? What is it made from? And how important to strength and durability? How closely should it matching the final production vision? Consider the product purpose. The professional who provides quickly prototyping service cannot determine the object of the design. That is something you must accomplish before starting a project. However, prototyping experience can assist you in determining the most productive, efficient, and cost-effective technique. Think and confirm the project deadline. Many people consider repeat prototyping service to to be fast manufacturing due to their expanded molding capabilities. However, some orders may take longer than others. Your project deadlines are crucial, but multiple variables could affect the schedule. Plan accordingly. Choose ways to with your team how you make cut costs while keeping in the integrate of your prototype design. Consider the impact of materials, accuracy standards, supplies, ISO standards, and industry trends on your final costs. Tips so selected repeat prototyping manufacturing. Selecting manufacturer to make your items is an important decision. Finding the correct match may be a difficult endeavor for any company. Before committing to any production resource, you must consider the cost, speed, quality, and manufacturing months. When you know what to look for, uh, collaborating with project prototyping business should be a breeze. Here are some elements to consider when looking for a manufacturing to bring your prototype idea to life. Industry experience. The best prototyping business will have uh, top lines when where you can look over their published work. This information is crucial in determining whether they have previously handled similar projects and specialized in the type of prototypes you require. You will require an experienced firm in your industry throughout this earlier stage of product development. They have a greater understanding of the materials to utilize, the machining that can be employed for the end product, and your industry term knowledge working with such prototyping business will greatly simplify the manufacturing process. Production capacity is crucial to the company's success. After launching a prototype, you must maintain subsequent orders within the specific delivery period, and the only way to help with this is to set the prototyping business that can handle and deliver huge order even after the prototyping phase is over. Do you do your homework before selecting a specific company or manufacturing to guarantee that the company can handle your type of business? This will save you money on chance and errors, as well as time wasted seeking a new manufacturer if you have a large order for your product. In the engineering and industrial sectors, ISO certifications and compliance standards are crucial. Certified prototyping companies have passed an audit by an impartial agency because they exceed the defined standards and provide super quality assurance. Choose, choose an ISO compliant business for higher quality prototypes. In any industry process, quality assurance is crucial. Working with business that building product, product prototypes ought to be of the highest caliber. A manufacturing that push optimize quality control is less likely to create parts or components that are flawed. Every step of the production cycle will see quality assurance testing performed by the repeatable business. If you, if you are an entrepreneur or working with prototyping companies for the first time, you may not have expertise in most manufacturing process. Therefore, it's crucial to ensure that the manufacturing partner you choose provides constant feedback and advice. A good prototyping company should always offer for your suggestions, advice, and options regarding the best material to use and the right process to follow. Therefore, if you are unsure about which process to use, there is no harm in seeking advice from the company. Making thousands of millions of identified companies or products at a cheap cost pure unite the main goal of modern manufacturing tools, and best practice. Customer and low-value production demands a wholly distinct set of techniques, and trying to modify mass production systems to fit presents special difficult for produce, and low-value manufacturing refers to production runs that manufacturing to a limited number of parts, ranging from 10 to tens of thousands. Most traditional manufacturing months, such as molding or forming, are designed for mass production, which involves producing large quantities of the same item. While those techniques are highly cost-effective for high-value production, like over 10,000 parts, they require standardized and expensive machinery and tooling, which rarely allow for production modifications. The cost is higher and the manufacturing time will be prolonged by weeks or months compared to large-scale production procedures like injection molding, and manufacturing can employ the high-value orders to affect those large upfront capital expenditures through mass production. As the cost of each part drops when it is spread over thousands of pieces, the kept to make specialized or highly customized parts at a reasonable cost is limited by the mass manufacturing procedures that are intended to generate identical parts in huge quantities. On the other hand, highly mass low-value manufacturing, sometimes referred to as customer manufacturing or production of goods according to special requirements, has historically been done by hand in intensive workshops. Because of the large percentage of manual labor and reduced throughput, this leads to a higher cost per parts for customer items. For the same reason, mass customization, the production of huge quantities of unique customers' goods, is really economically visible. Rapid prototyping can remove extra-habited model costs that need minimum orders to balance, lowering market entire barriers and promoting innovation in contrast to injection molding, which has significant model cost. Small batch production can gain advantages by reducing development time and shortening production cycle from months to days or weeks. Rapid prototyping can facilitate design changes and help achieve rapid iteration of products, create challenges, and response to customers' feedback, and have low cost. Customers may create goods with never before seen design freedom with rapid prototyping, including intricate sections made of organic and complex shapes, all at no extra cost. No, why maybe you want to know why choose Noble as the rapid prototyping and low-value manufacturing? That we have strong manufacturing capabilities because Noble providing various manufacturing months and advantages and advanced rapid prototyping manufacturing equipment and professional machines, allowing our rapid prototyping service to exceed competitors in the same industry far and meeting your immediate prototyping needs. Noble have excellent suppliers who can help us reserve the materials needed for continuous production, and at the same time strictly control the cost of each product within an affordable range and effectively reducing your project cost. We use high quality input materials and maintain a high level of process stability to ensure reproducibility. We strive for continuous improvement to improve our manufacturing of goods, process, and delivery capabilities. We have state-of-the-art low-value manufacturing equipment and had experienced team to help us meeting and exceeding your delivery time and quality expectation to ensure we deliver on time. Yeah, the above is the today's shares. So if you want to know more about the CNC machining technologies, you can follow us, follow us, and email to us. Any month you can contact us. We will reply in timely. So today, I'm very happy to you can listen to my sharing the information. So see you next time. Goodbye.